Well, good morning, or good afternoon, or good evening, depending upon when you're watching this video. I started today by writing stat 374 and not saying anything because I've had problems with the recordings picking up sound immediately. This probably won't work any better, but it was worth a try. So today we want to talk about frequency distributions. And this material, of course, is in your textbook. I believe it's the start of chapter 3, but you can use the index of your textbook and see what that is, see where that is. I want to tell you first of all what a frequency distribution is. And so we have a data set that we'll look at in a bit, but it's got 300 weights of human beings in it. 300 weights of human beings, 300 weights of people. Now, that is just a tiny bit overwhelming. You can't look at a piece of paper with 300 weights on it and tell what the biggest person is or what the average person is or how distributed that is. Are those weights all over the place, or do they tend to just kind of hug close to the mean? Does everybody weigh about the same? You can't tell that by looking at 300 weights written down on a piece of paper. So what we need to do is to do some organization, and an easy organization would be to create a frequency distribution. Now, take my word for this. I've used descriptive statistics in Minitab, and I've looked at the minimum and the maximum, and I found the minimum was 39 and the maximum was 150.4. And I really don't have the code book for this data, so I don't know if that is metric measures or if it's imperial. But you know, when I look at this now, these are adults, and I know that by looking at the age, which is also in this data file. And they're a mix of men and women, and it's just not likely that this is 150 pounds for the maximum weight of 300 randomly chosen people. So most likely this is in kilograms. So one of the things we're going to want to do pretty quickly is to change from kilograms to pounds. And why am I going to do that? Well, there are two reasons why I want to do that. One is we're generally more familiar with weights in pounds, and so I think maybe that's more meaningful to us when we look at a data set that have weights in pounds. But the other reason, and this is maybe a more important reason, I want to show you how to use Minitab to do the kind of arithmetic we need to do to convert these values in one unit to values in another unit. And I just can't help but think you're going to have lots of occasions to do that, more out of this course than in this course. But as you go through life and using some statistics, you'll be wanting to do some conversions. You'll be forced to. You'll have to. So I think version. So we can use kilograms to get the idea of a frequency distribution. So think of this as a number line. And on this number line, we've got our smallest weight, 39 kilograms, and our biggest weight, 150.4 kilograms. Now, in order to create a frequency distribution, we will decide that we're going to break all this data up into a number of categories or a number of bins. And then we're going to see how many people have weights that fall into each of those bins. And let me just do it visually, like that and like that and like that. We've got some rules of thumb here that I want you to know about. Like when I break this thing into bins, I want each of these to be the same width. So that's going to be an important consideration. each has to be the same width. Now, here's the arithmetic. We're going to calculate the range. And the range is a statistic because I'm going to compute it from a sample. My sample of 300 will have a range of the max minus the min. So it would be 150.4 minus the minimum, 39, and that would be 111.4, and that would be kilograms. All right, so the range is 111.4 kilograms. So whenever I decide where these breakpoints are going to be, I just have to make some decisions. Like if I've decided that I want 1, 2, 3, 4 categories here, then I'm going to take 111.4, that's my range, divided by 4, and that's 27.85 kilograms. If I want 4 of these to cover the whole gamut here from 39 to 150.4, this is the minimum width that they're going to be. Now, I'm setting this up, so I want to set it up so that it's convenient for myself. And so I'm going to say that we let the width of each group, but many people, Minitab included, call them bins. The width of each bin, let's say we let the width of each bin be 30 kilograms. Let the width of each bin be 30 kilograms. Now I know that if I've got four bins and they're 30 kilograms, then that would cover 30 times 4 or 120 kilograms, and I've only got to cover 111. So that's going to work. That's going to be good enough. Now we got to pick a start place. Well, my smallest weight was 39, so picking 40 as a starting place would certainly be a mistake because it would leave out at least one person, maybe more. So I need to pick a starting place that is at or below this minimum number. And I think maybe 35 might be a convenient place. So our start place, let's just say that we decide to make that 35 kilograms. Now, is that the only possible number we could have chosen? Well, no, heck no, it isn't. 38 would have worked very well. But if we do 38, it's going to make the arithmetic a little bit harder as we proceed here. So I think we'll stick with our 35. Now we can look at our low value in the bin and our high value in the bin. So the first bin would start at 35, and the bins are going to be, we decided, are going to be 30 kilograms wide, and so the high would be 30 kilograms further along, would be 65. And the next bin would be 65 to 95, just adding 30. And then 95 and add 30 to 120. 1, 2, 3, 1, 2, 3, 4. And then 120 to 150. Our bad luck. That didn't quite work out because I need to go up to 150.4. That's because I started just a little bit low. So what do we have to do? Well, it doesn't always work out the first time. We could adjust this by starting at 36. It's going to make the arithmetic a little harder, but if we did that, it'd end at 151, and that would contain our largest data point. So I'm thinking maybe that's what we'd ought to do. At least that's one thing we could do. Another thing we could do would be to make the width 31 instead of 30 kilograms, or even 35 instead of 30 kilograms. So what do you want to do? Well, this is a video, so you don't really get a choice. Let us decide that what we're going to do is to, I'm going to change color here. Oh, I love color. I'm going to change this. And what are we going to change it to? Let's change it again to keep the numbers sort of compatible. We'll change that one to 35. There is no significance to the fact that these are both 35s, just how it turned out. We're going to erase this for a minute, and we'll make our low value, well, we wanted to start at 35, and the high value 35, and then plus 35 would be 70, and so the low value would be 70, and a high would be 105. How did I get that? I added 35, and then 105, and then add 35, so you get 140. Sure hope I don't make an arithmetic error here. That looks okay. And 140 and 175. So 1, 2, 3, 4 bends. That's exactly what I wanted. And the low end point is 35. So that first bend would contain the 39, and the right end point of the largest category is 175, and that easily contains the largest value in my data set. So these will work. They are not the only choices, but they will work. Now this is, if you are reading your textbook, this is a bit of a departure from how Marty Triola has you set up frequency distributions. But I'm going to kind of stick with what I'm showing you right now, and I think you can stick with what I'm showing you and you're going to be okay. A couple reasons. First of all, what I'm showing you is much, much closer to what Minitab does when it does frequency distributions for us. And secondly, if we don't have integer data, if we have data with decimal digits in it, the procedures in your textbook really get confusing, especially if you're doing them by hand. It becomes very difficult to follow those. So I would kind of ignore those and really depend upon what I'm showing you in this video. But a question that you may be raising right now is, if a person weighs 70 kilograms, which bin is that person in? Is it in this first bin, or would that person be in the second bin? Well, we have to make a decision. And here's the decision that Minitab makes. The bins are from a low point to a high point, the low point being included in the bin, the high point being excluded from the bin. So that's the convention that Minitab uses. The statistical programming language R very easily lets you decide which way you want this to be. You can have it closed on the right and open on the left if you want. But we're going to do it the Minitab way. So closed on the left, open on the right. There's no question where 70 goes. 70 goes into the second bin because the first bin doesn't include 70. 69.99, that goes in the first bin. 70.00, that goes in the second bin. And I think that's enough. You get that. So we've got low value, high value. Now the next thing we have to do is to count. And here's all you do to count. you start through your data set. There are 300 weights in that data set, and you look at the first data set, and the first data set may be 120. So then you look at your bins and you go, oh, okay, 120 fits in right here, and so make a tally mark. Now go look at your second out of these 300 weights, and the second is 85, and that fits in this category, and so we make a tally mark. And then we look at the third, and the third is 132, and that fits in here, so we make a tally mark. And can you do that? Yeah, of course you can, but it's not much fun. I didn't spell tallies right, but it's not much fun. And you know, we really don't have to do that because Minitab will do that for us. Now, if we just wanted Minitab to do a frequency distribution, it will do it. It takes multiple steps, but it will do it. I mean, it's not that hard, but usually we don't use frequency distributions that much anymore. At a time, they were very important because if we were going to draw histograms, and that's a graphic that everybody uses a whole lot, if we were going to draw it by hand, we had to do a frequency distribution before we could draw it by hand, before we could draw a histogram. So we had to do a frequency distribution and then draw a histogram. We don't really have to do that now because Minitab will do the histogram for us, and then from the histogram we can work backwards and write down a frequency distribution if we need it. Very often we don't need it. All we needed was the histogram. So I think we need to rewrite some of these textbooks and get those things in the proper order for the modern day statistics student. Let's take a look at Minitab and see what this human data looks like. So I've got to find my Minitab. I won't scroll down, but there are 300 entries, 300 rows, which means 300 observations, which means 300 people participated in gathering this data set. The kinds of variables that we have, some people call these features, are age and gender and pulse, and then the systolic and diastolic blood pressure, and then we got some other blood chemistry here, high density, low density, lipoproteins, and then some cell count, white counts, red counts, platelets, the person's weight, and the person's height. And the weight, we kind of just went through that analysis a minute ago and said, you know, this has got to be in kilograms. It doesn't make sense otherwise. And then you look at these and you go, okay, well then that's weight in centimeters. And that works out about right. Weight in kilograms, height in centimeters. Let us go ahead and produce a histogram for the weight of these people. Now, maybe we're looking for a frequency distribution that looks like the one we constructed down here, that we constructed by hand. So a couple steps, but let's go to graph, and then the kind of graph we want is a histogram, and we want the simplest histogram. So this one's already lit up by default here. Black background means that's the one you're going to select, so we'll just say OK. And now, we've looked at this before, but now I'm going to have to fill out a little menu. And so what is it I want a histogram of? Well, there's something there, but what's there is not appropriate for what I want to do right now, so I'll get rid of that. We want to look at the weight. So here it is, C11, and I'll do a click, and weight is entered. And we need a label. Well, every graph deserves a label. So let's put a label on here. Let's type in weight of humans. Of course, I did that before I started recording. So weight of humans is the label, and I don't really have to have a subtitle, but I wanted one today, so I put units are pounds. Well, that's not true. Units are kilograms, and so let's change that. Units are in kg, in kilogram. And you know, something nice to put on a footnote, especially if you're going to be turning these things in, would be to put your name or identifier maybe in a footnote. So I'll just put my initials down there, and then we'll say OK on the label part of it. And I think we're ready to create a histogram now, so let's say OK there. Now I'm going to make this big, and I'm going to just look at my picture that we drew and get it so it fits nicely. Now here is a histogram. The histogram has bends, and here's a bend that's centered on 45. Now we were getting the left-hand endpoint and the right-hand endpoint of the bends, and then laboriously counting how many pieces of data fell into that bend. Notice that with Minitab, having created this histogram, I can just hover over a bend, and I can see this bend that's centered on 90, I see that from the bottom, has got 33 people that fell into this bend, and their weights were 87.5 to 92.5. Now that's not the frequencies that we came up with because we had different bends. Let's see if we can get the same bends in Minitab that we did by hand a few minutes ago. So I'm going to go to well, actually I create a histogram like I've done here, and then right click on any bend, and I can edit the graph. So I'll edit the graph, and Minitab gave me a new copy. I mean, it always does this. And let's right click again, and I want to edit the bars. And when I edit the bars, one of my choices is binning, B-I-N-N-I-N-G, and that's where I'm going to adjust my bends. So I have several options here now when I select binning. I can do intervals, that is bends, based upon the midpoint or based upon the cut points. Now 60 would be a midpoint, and 75 would be a midpoint, and 90 would be a midpoint. So the way this first histogram was drawn for us, it was based upon midpoints. But if we wanted to go instead to cut points are what we had when we were doing this by hand. So let's go with cut points, and then decide that what we want is to specify manually which cut points we want to use. So we work those out, and I wish I'd written them down. So our first cut point would have been 35. Now, whenever you specify a list here in Minitab, the separator has got to be a space. I would have made it a comma, I think. I don't know why Minitab did that. Maybe because in Europe they use a comma the way we use a period for a decimal point. So maybe it's better to use just a space. In any case, that's done. The cut points are separated by spaces. So what was our first one? It's not in my memory, but I can recalculate it because we made the width 35, so the next one would have been 70. And then after that, it would have been 105. And after that, it would have been, they're 35 wide, so it would have been 140. And after that, it would have been 175. And let's see, that's 1, 2, 3, 4. And our biggest was 150. that's where we were. So that just types in what we had computed by hand earlier. So let's say OK. Now that's changed our histogram. This is the first bin, second bin, third bin, fourth bin. That is a terrible histogram, but I created it because it does go with that computation we did by hand. So these are the bins that we computed by hand. Now we don't have to count how many people fall into this first bin. I see that the first bin goes from 35 to 70. We knew that already. But I also see that there are 91, the bar value, 91 people fell into that first category. So I'm getting a frequency distribution. I'm going to make a little note. My first bin was 91, was 35 to 70, 91, and 70 to, my second bin was 70 to 105, 70 to 105, and my frequency was 176, and my third bin was 105 to 140, 105 to 140, and my frequency was 30, and my last bin was 105 to 175, and my frequency probably is 1. No, it's 3. My frequency was 3. Okay, now if I really needed a frequency distribution, I would have one now. And here's what a frequency distribution looks like. For a frequency distribution, we can put the low value, the high value, and the count. And that would be 35, 70, 91. 70, and you know, I think I'm going to write it this way so there's no confusion. 105, 176, 105, 140, 30, 140, 175, 3. And there is a frequency distribution. You will not very often be asked for frequency distributions. You might be, and you certainly have the capability now to easily construct a frequency distribution, but more likely will be after the histogram. Now, just some general thoughts on histograms. Here I had a pretty big range, from 35 to 175, pretty big range. And the problem with making just 4 bins or 4 classes is that I've got weights in here from 35 to 70, and that's quite a bit of width there. A person that weighs about 35 pounds probably doesn't share many characteristics with a person that weighs about 70 pounds. A rule of thumb is, when you create a histogram, to have usually an odd number of bins, and maybe to have something in the 7 to 11 range for the number of bins you have. The compromise is, if we have too many bins, our picture is confused because there are just too many bins in it. It's almost as confusing as the data that was on the first page that we were trying to simplify anyway. And if we don't have enough bins, we're lumping together things that really are pretty different, don't belong together. Usually something between 7 and 11 is just about the right number of bins. So why don't let's just get rid of this little thing we did for illustration, and why don't we come back to our histogram and edit this graph And we're going to work on edit the bars and go back to binning again. This is an important little diagram. It does a lot of neat stuff for us. I'm going to select midpoint here instead of cut point. And I'm going to select a number of intervals. And I'm going to select 11 intervals. Now, these are what we call radio buttons. You can only select one of them. If I select automatic, then my number of intervals goes away. If I select number of intervals, automatic goes away. I can only select one of these. I can let Minitab make all the decisions for me. That's automatic. I can select the number of intervals or the number of bends that I want, or I can specify where I want cut points or midpoints. And I've said now I want midpoints and I want 11 bends, but I'm going to let Minitab do all the computation that we were doing previously on the graphics tablet. And that's what it looks like. Boy, that didn't take very long, did it? So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bends. That's what I asked for. We've identified not the cut points, left end, right end, but the midpoints. Generally, I think the midpoints are better to put on a graph rather than the cut points. And if I need a frequency distribution, I can just hover over one of these bars, and I see this bar has cut points, left end point, right end point, of 65 to 77, and there are 67 human beings that have weights between those two limits. If I want to, I can put numbers on every one of these bars. The graph can get too busy if you put too much on. So those are all kind of artistic footnotes. You have to decide what looks best for your purposes. And feel free to play around with lots of different values on these histograms until you get something that is telling the story that you're setting out to tell. And I don't mean making up something story in that sense. I mean telling how you interpret the data, sharing with other people how you interpret the data. You know, the old adage, a picture is worth 1,000 words. A quick way to convey to someone else the meaning that you see in the data is with a picture, i.e., is with a graph, and histogram is the first graph that we'll learn to draw. And this has gone on kind of long, but I think we'll do one more thing before we quit here, and I'm going to show you how to convert those kilograms back to English measure. So here I've got the weight, and this is in kilograms. Now over here, I wonder if I can just get rid of that. Over here I've got C16, a blank cell. I don't have to use C16. I could come over here, and I guess I will just for illustration. In C17, I'm going to put the weight, but I'm going to convert it to pounds. And so this first cell right here, this is a label. And if I put my cursor on that first cell, then I can label that weight, WT space LBS, weight in pounds, so I'll know what that means. Now there are 300 weights, and I'm going to convert those to pounds. Now let me share with you that, and so that I don't make a mistake, I'm going to find a note that I made earlier, that 2.2046 pounds is equal to 1 kilogram. So if something weighed 50 kilograms, I could multiply that by 1 and it would still be 50 kilograms, right? But since these two quantities are equal, I could create a fraction 2.2046 lbs over 1 kg. Now this is just 1 because what's in the numerator is equal to what's in the denominator. Now if I would treat my units like they were just any other numeric part of the equation here, of the computation, then a kilogram in the numerator and a kilogram in the denominator cancel out. Now see that the units are just pounds, and so 50 times 2.2046 lbs is the same as 50 kilograms, and that's going to be a little over 100 pounds, right? We don't care so much what that really is. But what this does is keeps us from making a mistake. We know that to convert kilograms to pounds, we want to multiply the kilograms by 2.2046. So let's go back to Minitab and see how we might go about doing that. I don't really need that graph there, so maybe I'll just give us more data area here, and I'll move over just a little bit. These things are a little bit hard for me to see in the light I've got in this room. All right, so here we are. We've got a new column where we're going to create weight in pounds, and I've got a column that already contains weight, and I certainly don't want to take these one at a time and multiply and write the answer down over here. But if we'll go up to the top tabs and go to the Calculate tab, the first thing we have there is a calculator. And you know, I'm thinking I'm not recording that part of the screen, so let me do something else. Let me do that here for just a second. I went up to the Calculate tab and noticed that under the Calculate tab, Calculator was the first entry. Now, I'm going to calculate something with a calculator that's built into Minitab, and I'm going to store the result in what variable? I could just say C17, but since I've already named C17, it appears in the list over at the left, and so weight in pounds, that's where I want to store the weight in pounds, and so I'll select that. Now what is the expression that we want here? Well, the expression is going to be, just think about how you would do this if you picked up a piece of paper and a pencil. You would take the weight, so I'm going to double click that, and you would multiply that. So I can either type from my keyboard the asterisk, which we use for multiplication, or I could come over here and I could type this little asterisk that's on this little mini keypad here, this virtual keypad. Either way, times 2.2046, and that's plenty of decimal digits, and that's all there is to it. That's all that we need. So I'm going to say OK, and look, the conversion is done. This column is the same as this column, except these weights are expressed in the units pounds, and these are in the English system. Now, an annoying thing is that these have 3 decimal digits. We can control the decimal digits we want. Let's go back to Calculate and bring up our calculator again, and I'm going to erase this formula, although we could edit it, but I'm going to erase it. And you know what we want to do over here is round these to one digit. So if I look through the available functions for this calculator, if I just kind of peel down through these functions, L, M, N, N, O, P, wait, I went too far. Here's a function that's called round, and I'll bet that's the one I want. So I'm going to select it, and round, it even prompts me here. the number I want rounded and how many decimal digits I want. Well, what is the number I want rounded? It's going to be the weight, so I'll double click that, times 2.2046, and then comma, this is just a little tiny. I wish it was bigger. Maybe I can make it bigger. I'll work on that. Comma, how many decimal digits do I want? And I just want 1. So now we're using two functions. We're using multiplication to convert our weights to the English system, and then we're using the round function to round that result to 1 decimal digit. So I think if we just say OK, here's the results, and that's kind of the way we want it. So good for us. I'm going to save this data set. I'll have to write you an email about it because I'm going to put it in OneDrive, and I'll have to give you a password and some other things to get into OneDrive to get this data set. But I'm going to ask you, as soon as I get that to you, to go ahead and convert the height, which is in centimeters, convert that to inches. And just as practice, don't worry about turning it in. It's just a matter of getting Minitab running and loading up your data set and seeing if you can do something with Minitab. And then you might do some histograms of the height and the weight, and just play with Minitab. There's no other way you're going to get familiar with it, and you're going to learn some statistics as you're doing that. So I don't want to go any longer on this. I'm going to quit, and I'm going to thank you very much for your attention as we worked through frequency and histograms. You have a good day.